Hello and welcome to T-Level Tactics and this video on algorithms for Root Core 4 Digital Analysis of the T-Level Digital Support Services course. And in this video we're going to define what algorithms are, we'll identify the characteristics of an algorithm, and we'll also create a simple algorithm together. Before we get started, these videos are not endorsed or sponsored by any education institution or qualification awarding body, and T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation material or as a revision to reinforce your learning. These videos also cover the same content and required knowledge for Root Core 4 of the T-Level Digital Business Services course. However, it will be more contextualized towards IT support roles. Let's get started. Now, you've probably heard about algorithms in connection with social media platforms, things like the YouTube algorithm, the Twitter algorithm, or the Instagram algorithm, these mystical things. And it's true. These platforms do use algorithms to show you content. But algorithms are also used elsewhere. Other websites make use of algorithms. Most computer programs use algorithms. In fact, you probably use algorithms in other things in life as well. So, what is an algorithm? Well, an algorithm is just a way of solving a problem or doing a task, according to a set of rules or guidelines. It's often a procedure carried out in a specific order and performs to achieve a certain goal. Think of baking a cake. You have to do certain things in a certain order to get a specific end result. You have to combine ingredients in specific quantities in the correct order before baking, and you can't add ingredients you've missed after it's been baked. It's too late then. You need to use an algorithm in order to get the right result. There are three main types of algorithms: sorting algorithms that organize data in a specific order, search algorithms that retrieve information from data structures, and optimization algorithms that find the best solution among many different possibilities. Algorithms are used in search engines to rank results on relevance, for instance, recommendation systems to suggest products, data processing, financial modeling, cryptography, risk assessment, and many more areas as well. Algorithms are essential for processing and analyzing large volumes of data, and they help to automate decision-making processes and enhance efficiency. So understanding algorithms is going to help us to develop efficient solutions to complex problems and develop problem-solving skills that were useful in a wide range of fields. So if you're a Patreon member, you can head over to patreon.com/T-Level-Tactics and download the task sheet. And if you're not a member, I suggest you head over there to see all the great exclusive resources that our members get. Once you've got the task sheet, have a go at the first task. It's only a short one. It will take you about 15 minutes. I suggest you pause the video here, have a go, then come back when you're ready to move on. So what do algorithms look like? Admittedly, algorithms are a bit more complicated than just a set of instructions. There are certain characteristics that define them. Algorithms are finite, unambiguous, have clearly defined inputs and outputs, have a logical sequencing of steps, are iterative, are selective, and are structured in English. Let's take a look at what this means. Algorithms must consist of a finite number of steps. This ensures the algorithm will eventually terminate and produce a result. Otherwise, the system and the data you're trying to process could be stuck in an endless processing loop, and we need to avoid that. Each step in the algorithm must be clear and precise. and every instruction should convey exactly one meaning to ensure consistent execution. And this avoids any ambiguity, ensuring that each instruction is interpreted in one way, and helps to ensure that individuals with varying levels of expertise can understand the algorithm when they read it. With clear inputs and outputs, inputs is the specific data or parameters that the algorithm requires to function, and outputs are the results or outcomes produced by the algorithm after processing the inputs. And algorithms should include mechanisms to validate inputs to ensure they meet the required formatting constraints before actually running their code. And they should also specify how to handle invalid or unexpected inputs, including things like error messages or fallback mechanisms. The steps in an algorithm must be arranged in a logical order to ensure proper execution. And each step should follow logically from the previous one, leading towards the final output. The order of steps is crucial for the correct execution of an algorithm. Changing the sequence can lead to incorrect results or unintended behavior. Think back to the cake and how you had to mix ingredients in a specific order to get the right result. Algorithms often involve repeating certain steps until a specific condition is met. This is known as iteration, and it allows for processes like loops to refine results or continue calculations and performing the same step multiple times. There are 3 different loops that can be used. For loops, which executes code a predetermined number of times. While loops, which can continue executing code as long as a specific condition remains true. And do-while loops, which is similar to a while loop, but guarantees at least one execution of the loop body. Algorithms can include decision-making processes where different inputs lead to different paths or steps. And this means we can use conditional logic, allowing the algorithm to adapt based on varying inputs. We can use things like if-else statements, which execute different blocks of code based on whether a condition is true or false. We can also use switch statements, which select among multiple options based on the value of a variable it receives. And finally, algorithms use structured English. This is essentially a simplified, structured form of the English language that algorithms can be written in. This enhances clarity and understanding while remaining accessible to both technical and non-technical audiences. It makes algorithms easier to understand and communicate, especially for non-programmers. Structured English is a type of pseudocode, and pseudocode is essentially written like computer code, but in a more understandable form. Let's take a look. We'll take a look at a simple algorithm. This is its structured English format, or pseudocode. This algorithm looks at a list of data input by a user, which is a list of numbers, and compares each value to find the highest and tell the user what it is. This algorithm has a clear purpose. It has an iterative loop. There's a for loop in there. It will run for as many items in the list, and no more, and will return a definitive result at the end. It also uses understandable terms to help understand what's happening. So what does the algorithm do? Let's break it down. First, it starts. It creates a variable called max and sets it to the first element of the list. For each number in the list, if that number is greater than the one we've stored in max, then we change the value in max to the number we're looking at. We'll do that for each number in the list until we've run out of elements, and then we'll end the for loop. We'll then return the value that we've stored in max as the highest number in the list, and we'll end the loop. So that's understandable to us, but what does the computer do to run that? It will receive the input list. In this case, we've used the numbers 3, 5, 2, 8, and 1. The first step will set the max variable to 3, as it's the first number in the list. Step 2 will compare the number 5 with the number we've stored. As 5 is greater than 3, we'll change the max variable to 5. Then, the next element, which is 2, we'll compare it. As it's not greater than 5, max will remain as 5. Then we'll compare 8 with the variable stored in max. As it's greater, we'll change max to the number 8. And then finally, we'll compare the last element, which is 1, with the number stored in max. As 1 is not greater than 8, max will remain as 8. We've now gone through all the elements in the list, so we'll output the number that we've stored. So, for Patreon members, you can head back to the task sheet and have a go at task 2. This one will take you a little bit longer, and I will look at some algorithm examples. Spend about 20 minutes on this. So pause the video here, have a go, and then come back when you're ready to move on to part 3. So how do we create algorithms? Let's find out. To create an algorithm, it's best to have some understanding of computational thinking. And we're going to go into that in some more depth at a later video. But we'll use a simpler method for now. To create an algorithm, we need to understand what problem we're trying to solve. We need to define some inputs and outputs. We need to outline some steps to solve the problem. And then write out the algorithm in structured English, or pseudocode. For this example, let's say that we want to find out if a number is considered to be a prime number. Remember, a prime number is a natural number greater than 1 and cannot be divided by anything other than 1 or itself. Fortunately, we don't need to do the calculations ourselves for this. We just need to create a way for a computer to do it for us. Our only input in this algorithm is going to be a number that a user enters. It could be 7, 12, or 1587. It really doesn't matter. Our output just needs to tell us if the number is prime or not. So our output could be Boolean, which means if it's true, then the number is prime, or if it's false, then it isn't. So now we just need to figure out how we solve this problem. How exactly do we determine if this number is prime or not? Well, we already know that if the number is less than 2, then it cannot be prime. So from there, we just need to check if the number is divisible from 2 up to the square root of the number. And if the number is divisible by any of these, then it's not prime. Otherwise, it must be. So now we have all the key elements that we need to start writing our algorithm. First, we need a start. Then, we can use a conditional statement. Is the number less than 2? If it is, it can't be prime, so we can return false to the user, and we end our algorithm there. What if it's not? Well, we can use a loop. For each number between 2 and the square root of the number, divide the number. And in this case, we're using an operation called mod, or modulus, which will divide the number and return anything left over. If there's nothing left over after this, then the number can be divided evenly by something other than itself or 1. Therefore, it cannot be prime. So we can return false to the user. And if neither of these statements is returned false, then the number must be prime. So we can return true instead. This pseudocode is very logical, but not all pseudocode needs to look this way. You can write pseudocode almost however you like, as long as its intent is clear and it's in an order that makes sense. Now have a go at coming up with your own algorithm. It could be maths related, or you could think of a real-world process and write out the pseudocode for that. For instance, if you were going to make a cup of coffee, what would the pseudocode look like for that? Now for Patreon members, you can head back to the task sheet and have a go at task 3. This one's going to be a little bit longer. You're going to create some algorithms. It will take you somewhere between 30 to 45 minutes. So pause the video here, have a go at that, and then come back when you're ready to finish things off, and we'll have a couple of short exam questions. So in this video, we've defined what algorithms are. We've identified the characteristics of an algorithm. We've also had a go at creating a simple algorithm together as well. Let's have a go at some short exam-style questions. Here's the first one. Explain the concept of iteration in algorithms. And the second, give 2 different examples of where an algorithm could be used. That brings us to the end of the video. In the next video, we'll be looking at where algorithms can be used in life and in industry, and some different examples that we'll analyze in some detail. So make sure you're subscribed to youtube.com/@tleveltactics to be notified when that video comes out. And if you're not a member yet, head over to patreon.com/tleveltactics to take a look at all the great resources that our members get access to, including our exclusive Spotify podcast editions. Thanks for watching, and see you next time.